Alright, what's up guys? So for this exploration, we're just going to introduce logarithms. We're going to define logarithms, finally tell you what this mysterious word means, and also learn how to use logarithms to rewrite exponential equations, and thereby being able to solve exponential equations. Alright, so before we get started, we're going to kind of warm up with building on some background knowledge, showing you that you already have all the pieces and the skills and the content you need to learn logarithms. So let's solve for x. So we've been learning exponential equations recently. What's the value of x? I'll give you a second. All right, so hopefully you were able to just kind of look at it and think 4. So obviously the value of x was 4, and it's just because 2 times 2 times 2 times 2 is 16. So if we take 2 and multiply it by itself 4 times, it'll give us 16, yeah? So just remember, just to build on some background knowledge and refresh your memory before we move on, the base is 2. So when you're dealing with a power here, the big number is the base, B for big. So big number is the base, the little number up top is the exponent, all together it's a power. All right, so now let's try a more challenging problem. So what is the value of x here? In other words, what number can you multiply 2 by itself multiple times in order to get 20? Don't know. So obviously that was a bit of a trick question. So I would never expect you to know this unless you're an absolute math wizard. Actually, the answer is 4.32192809489. And the way I did that is using logarithms and obviously a calculator. So you can check this out in your computer real quick. Just go to Desmos and type this in. You'll see that if you type in 2 to the 4.3 yada 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 power, it'll give you 20 exactly. And I found this using logarithms. And this is what logarithms does. This is what a logarithm is. It's essentially a way to figure out, well, what number do we have to raise another number to the power of in order to get a third number? So loosely speaking, a logarithm answers the question, how many times do we have to multiply some number to get another number? Another way of just communicating this using some of our vocabulary is what exponent is needed to make the power with base b equal to some other number. All right, and in case you're wondering, logarithms are used a lot in the real world. You might not use it as you grow up, but a lot of people use it every day, particularly in finance, data, computer science, economics, biology, physics, chemistry. Basically, they're used whenever we're dealing with exponential growth or decay, whenever we want to measure how something grows over time. So obviously, all these things deal with change over time, measuring how things grow over time. So they also come in particularly handy when you're dealing with orders of magnitude or measurement scales. When you're dealing with really, really big numbers or really, really small numbers like we deal in all the sciences. For example, Richter scale measuring the magnitude of an earthquake, decibel scale measure the loudness of a sound. And then things called log graphs, which are used in computer science to take information that seems to be like wildly varying and not really correlating. And then you can create a log graph to show the correlations between variables, brightness of stars in astronomy, as well as pH balance in chemistry. All right, so let's try an example. What exponent is needed to make the power with base b equal to some other number? For instance, what do we raise 3 to get 81? Hopefully you're able to think again 4. And this is how we write logarithms. Say log to the base of 3 of 81 is 4. So if you notice, the logarithm is just the exponent. That's what a logarithm gives us. It tells us the exponent to which we need to raise some number to get a second number. So we can say the logarithm is what exponent is needed to make the power with base b, in this case the base is 3, to some other number, in this case 81. So again, you can see the connection here. When we're taking an exponential equation with base b, that's what we're dealing with in the logarithm. What number do we have to raise base b to get 81? In this case, it's 4. And so here's another way of kind of seeing it visually. You can see the connections here. When we're writing a logarithmic equation, we take the log of the base of the power, and what we want to do is find what exponent do we have to raise 3 to get 81. So 81 here is the input. We need to figure out what number can we raise 3 to get 81, and the answer is 4. So this is kind of like a mathematical equation in which we say this right here. All right, so you try. Convert this exponential equation into a logarithmic equation to find the value of x. I'll give you a second. All right, so hopefully you were able to first take the format of a logarithmic equation, which is log b of y is equal to x, and just make the connections where the logarithm, so we put x, the exponent, to the right side of the equation. That's what we're trying to find. That's our output. The base b, so you put it down here. So we say log, excuse me, of base 4. So we say log of base 4 of y is x. Well, remember the idea is we're trying to figure out, well, what exponent do we raise this base to get this number? So that in the logarithmic equation is we say log of base 4 to get to this number. So that's the number we're looking for, so we need to substitute that number in there. So there we go. So this is our equation. And again, this is read aloud as the logarithm of base 4 of 122 is x. Another way of saying is the logarithm with base 4 of 122 is x. And if you type it into your calculator real quick, you could find that it gives you this big old number. So basically what this is saying is if we want 4 to turn into 122, we have to raise it to this power. So often you can just round it to 4 or 5 decimal places, which I did there. And there's your logarithm. The logarithm of base 4 of 122 is roughly 3.4654. That means that we can raise 4 to the 3.4654 power and get approximately 122. All right, your turn. So time to do some critical thinking. Let's flip it around a little bit, and now you rewrite the logarithmic equation that I've given you below into an equivalent exponential equation. So I'll give you a few moments to do this. So the first one, as you can see here, we're just flipping it. So we're taking the base right here. So that's our base. That's the first number you write. Our logarithm, which is the exponent up here. So this equation is saying that if we take 5 to the power of x, we should get 3. So if we take 5 to the power of x, we should get 3. And there you go. And it's helpful to kind of read it out loud to make sure you don't make any mistakes like that. So for the second one, if we want to find the logarithm of base 9 of 243 is equal to 5 over 2, that's saying that if we took the base 9 and we raised it to the 5 over 2 power, we should get 243. And there we go. And then lastly, the equation is saying if we took 81 and we raised it to this 1.5 power, it should give us y. And there's your answer. So again, the connection is if you want to convert a logarithmic equation to an exponential equation, you take the base, you raise it to the exponent, and then your output will be this value. And so hopefully you're starting to see a connection. It's very similar to inverse functions that we've learned last unit. We'll talk about that more in the following weeks. But yes, in case you were wondering, exponents and logarithms are inverse functions. You can see here that the input for a logarithmic equation right here is the output for an exponential equation and vice versa. But enough for that for now. All right, more practice. Use some critical thinking and your calculator now. So just kind of remember the stuff we learned last week with solving exponential equations. How would you solve these two exponential equations using logarithms? Hint, change these to logarithmic equations first and then put them in your calculator. All right, so for the first one, hopefully you were able to see that you took the base 2, and we want to find the value of x here. So we take base 2, and then we want to figure out what power of x can we raise base 2 to get 55. If you plug in this expression into your calculator, it should give you approximately 5.781. Meaning if you raise 2 to the 5.781 power, you'll get about 55. And then lastly, this one was a little tricky, but hopefully you were able to remember what we learned last week when solving exponential equations. The first thing you got to do is get the exponent by itself on one side of the equation. So I just subtracted 10 from both sides, and that would give me 119 over here. And then you can convert 5 to the x power is equal to 119 into a logarithmic equation. So basically what this is saying is if we took 5 and we raised it to about 2.969, it would give us approximately 119. And remember, it's 119 because I first had to subtract 10 from both sides. All right, and that's it. So please return to the general meeting so we can close our lesson today and we can check for your understanding using goformative.com. Later.